So in this last session, we get back to code and more code. So try to keep the slides short. And the idea is to, well, try to show surprising code. Now, you might be very experienced or not so. So it could be totally confusing code, or yes, I do all of this stuff. So it's different because then it's a varied audience. And yes, you have different, not just maybe different number of years of using the product, but also different ways of using the product and using the most recent language features in the product. So it's supposed to be a deep dive, so I'm not going to touch on the basics at all. Just a little bit of introduction about, well, before I do that, well, I'll do that next, then I'll forget, I'm sure, but let's try to do that again. Language timeline and some general considerations. Delphi language, live and kicking, still very popular. I mean, all of these indexes and numbers are hard to manage. But still, I mean, it's still popular. And again, we're kind of pushing it up a bit with the free tooling. Great heritage, dating back to very, very old days. What's the compiler number version? Is it 30 something? Yeah. I think we're on a 30 version of the Object Pascal compiler product line overall. So it's been quite some time. Well, in fact, it's from '83, so it's quite some time. Great heritage, continually evolving, and we keep it moving, and we want to keep it moving. We'll get to that. One big thing of the last few years that we went from using one compiler, Win32, to 8 compilers, which is what we're shipping today. So today, if you get Enterprise, not other versions, you get the Enterprise, you get 8 compilers. Win32, Win64, OS X, which is 32-bit for now, iOS Simulator, which is also 32-bit for now, iOS 32, iOS 64, Android 32, and Linux 64-bit. So it's a mix of 32-bit and 64-bit compilers. It's a mix of Intel and ARM compiler. And it's a mix of compilers built with the old compiler technology or based on LLVM architecture, last support. Okay, and I don't really want to get into the nitty-gritty details of one or the other, what's happening. We can discuss. Definition of the languages, I'm like quoting myself, it's not great. Power and simplicity, expressive and readability. So the fact that, I mean, can be used for learning, but can also be used for professional development and large and small applications. And it's really very flexible what you can do with it, thanks to the language and thanks to the library that come along. But still, I mean, the language matters quite a bit. So that's the point. So that's history in a few dates. Again, 83, 95, kind of the big year. 95 remains the most relevant year for the recent history of programming languages. I mean, in 95, Delphi came along, not the most popular one. Java came along, JavaScript came along, plus Ruby and PHP. So it's, I mean, if you take these 5 languages, I mean, it's quite a lot. It's quite a lot of programmers using those 5. Okay, to move somewhere it doesn't. Okay, so, and again, it was a good year. And that's important to remember because at times, I mean, you got to say, oh yeah, using Delphi is old, I use Java. Yeah? Is it your? Or using JavaScript. Well, you might be using it for a different purpose because web and everything, but in terms of older newer, it's exactly the same year. So come on guys. I mean, old and new doesn't really mean much. So again, you can say, hey, it's more popular or not, that we can discuss. But in terms of being newer and older, the newer languages are really C#, it's a little newer, not that newer, but a few years later. And Swift, that's pretty new. And then some of the new languages like Go, Dart, all of these oddly named ones. I mean, there are newer languages. Some of the functional languages are new, yeah, it's fine. But if you look at the most popular ones, I mean, C and C++ are significantly older, and although C++ has been evolving. But anyway, so 2009 is kind of the year we got like the core, the modern Object Pascal, we tend to call it, so generic anonymous method of reflection attributes. And then going to, I mean, the first LLVM-based ARM compiler, that's kind of, it's not a big change in the language, but certainly like opening up the language to way more platforms. So the first thing I'm going to do is kind of focus on the modern language, so generics, anonymous methods, and the like. But I'm not going to tell you, hey, this is generics, this is what it's used for, this is the demo. I'm going to use slightly unusual or uncommon ways of using these language features. Again, more to touch on what can be done than really, I mean, do the classic like training. This is how you do things. And the main point, I mean, there are two things that are relevant at a general level. One is these features don't add something to the language, but they allow you to use the language in a completely different paradigm compared to object-oriented programming. I mean, generic programming, or the use of anonymous methods for functional-based or function-based programming, or use of attributes that allows a lot of, I mean, the generation of dynamic code, I mean, very dynamic code. I mean, these open up the possibility to use a different paradigm altogether, not just it's an additional feature. So that's why they're important, because they open up the language for completely different uses. Now, they're not used by the majority of the Delphi developers all the day long, for the good or the bad, but they open up a lot of opportunities. So again, some of the code I'm going to show is kind of getting glimpses of this, like alternative ways, alternative opportunities, more than, again, teaching the features in themselves. So generics are parameterized type, and as we'll get to, anonymous methods are, you can allow you to pass a function as a parameter. So these are kind of the two things that make those models different. So before we get into the, and I have slides, but I just ignore the slides and go through the tables. The question I need to ask is who is regular, I'm not saying every day, every line of code, but who's regularly using generics? Okay, anonymous methods. Somebody RTTI reflection, method invocation things. Okay, it's going. Oh, it's fine. Generics is almost 50%. So maybe you don't all get completely lost in the next demo. Oh, who's using interfaces? I'm nothing with interfaces. I decided, okay, I need to. I could go on. I mean, I could go on like 2 days with this stuff. So I had to trim it down to 1 hour. So anyway, so let's get going. So the first thing, and I'll try to explain you what I'm doing here, and then we can see a little bit behind the scenes. Wow, this is really hard. I mean, just we only need to see the source code, so the UI doesn't really matter. So it's blurry. I don't know how to do it. It's good on my screen. So what's the point here? What is a smart pointer? The concept of smart pointer comes from C++, where in C++ objects can be managed or unmanaged. When they're dynamic, there are ways to kind of simplify or automate the memory management. In modern C++, there is a keyword called auto for that, but in the old C++ days, you create a class to manage the lifetime of another object. I mean, an object to manage the lifetime of another object. This is kind of the idea. We want to be able, to write code like this that does create a memory leak. It's something that's as close as possible without having the memory leak, but of course without adding the free statement, because that's the easy way to avoid the memory leak. Say, use this object and then get rid of it when it's done, kind of code. So this one will not work, but those below, and in particular, one is very similar, but does not leak the memory. Okay? So what it's doing in this code is, rather than creating a string list, is creating this special purpose smart pointer object. And that's what's declared, the data type, and then uses it as a string list, kind of. So it assigns a string list to this object, which is kind of surprising, because what the heck was the compiler thinking here? Assigning something to something else, it's not complaining, it's compiled, it does work. And then we use the value to call methods, so value.add, value, and so on. Or you can do a cast. This is also quite surprising, casting something else, and it doesn't work. So again, it's fairly confusing and fairly complex code. Again, the point is to be able to manage the memory, avoiding the free statement. Now there are other ways, but this again, for the sake of doing something weird with generic. So, of course, the problem becomes, okay, if you're creating an object instead of another object, what's the difference? And you still have to edit matter the first one. So, which is the data structure that Delphi has that does not need create and delete because it's allocated locally? It's not a class or an object, but it's a record. So the smart pointer, in fact, is a record. There's no way to implement this with an object. It has to be a record. Because the record, the record is not really allocated, but somehow, when the code starts, it kind of goes away when you go to the end. Now, that goes away is kind of tricky because it goes away, but you need to tell me, hey, when you go away, get rid of the object. So that's kind of the tricky part. Okay? So first thing is a record. However, if you build a simple record, you'll be in trouble because then you'll have to do like a million unsafe typecasts all over the places. But this record is a special record tied to the data type, and that's where the generic thing comes in. So it's a generic record that can actually hook to the data type. So this is the actual definition of this class. Okay. So whenever you say this smart pointer of something, you're saying that the value you're creating with the type of value, the value property is that specific data type, that specific object type. So you don't need to any cast, and at runtime it's fast because this is all resolved by the compiler. There's no runtime thing behind the scenes. It's really very fast. Okay, so second question is, okay, how comes the record can do something when it goes away? It cannot, well, kind of. The record has a constructor or a finalizer, something we're considering, but it's not there. However, if a record includes internally a managed type, like a string, it will get rid of the string. If it includes a managed type, like an interface, it will get rid of the interface. And you know what? I've added an interface, print the value of an interface. So whenever the record goes off the scope, the interface is the reference, and if the interface count goes to 0, the interface destructor, the destructor of the object you're using to implement the interface is being called, and in that call you say, hey, get rid of the objects that's associated. So this value is destroyed by the destroyed internal object that implements the interface. And hey, it works. Now the last bit, how you can assign an object to an object of a different type? Well, that's the magic of the implicit class operator. The implicit operator redefines, well, not assignment, but conversion. So you can convert this into this, a smart pointer of t into a t, whatever t is. It's defined for any data type, it's generic. And so it works. You can assign, copy in and out from the object to the smart pointer to the actual value, vice versa, just using these conversion operators. So, yeah, this feature has been in the language for some time, but kind of creative ways of using them. And well, if you prove it works, you just run it, and use the smart pointer, there's no memory leak, use the first code, that's the memory leak, and yeah, we have a memory leak. Even more surprisingly, I've actually extended the syntax even a little more. So this one is the shorter version. There is even a version that does not create the object. It's created as needed. How nice is that? So basically, when you're accessing the value, the code here for the get value basically says, it's not down here. If it doesn't exist, create one. And this is because you can create, create one, but then to create one, it does this create, t.create. It can create the object of the generic type. Just because we told him, hey, it has a default constructor. So that's kind of the limit. It only works if there is a default constructor. Otherwise, it's messy. Okay, so that was one thing about generics. The other thing I want to show you, I need to go faster. Everything here, just to go faster. This is another trick. Consider like a classic hierarchy of animals, I mean the cat and the dog. If you have a method, a virtual method in the base class, you might want to say, hey, return if the class has the animal, it has a method that returns at the animal. When you're calling the method for a t-dog, you want a dog back and not an animal. This is called covariant return type. Some languages support it, Delphi language does not support it. But there are sort of ways to implement it using generic methods in non-generic classes. So this get says return an animal, and it will not work. It is not flexible. But this get as, which is a generic method, can in fact return t. So you can write the code. This is how you write standard code, get as the object. You can write it slightly different, which is calling get as and passing the type that's expected as a return value. It's not that different, a little different. Basically, the conversion happens inside the method, but then it's type safe. You don't have to cast out what's returned by t-dog. Okay? Now, the thing that I don't like here is that you say t-dog create a t-dog, which is, yeah, sure, you're kind of repeating the same type twice. But that's not really needed. And I've done it with a separate class, but they've done the same class. You can actually have a function that's not associated to the type, but that returns an object of the given type. So this shop, just a placeholder for a kind of a global function. The shop has get as and t as parameter. Okay? So here there's nothing to repeat. So get as t-dog, so create an object of that type and return it of this specific type. Again, it's kind of a trick, too fancy. Anonymous methods, I'm going to show 3 things about anonymous methods, kind of a nice thing. One, it wasn't working yesterday, it's not working today because they haven't fixed it. It's something you've seen, calculated fields. Who has done calculated fields? It's kind of common. Now, the thing I don't like, it's not great about calculated fields, that you add one, and then you have your own calc fields, and you have a calculation. Then you have a second, and two calculations. Then you have a third, and you have 3 calculations. You say, oh, I want the same calculated fields in another place, and you have to grab that piece. It's kind of inflexible because it's one method for the table. So what if you could have, for each calculated fields, anonymous method tells you, hey, this is how you calculate it. Yeah, so each field has its own. And this is what this program does. It basically allows you to, allows you to write something like this. And again, I'll leave you the code as an example. Client data set, add extra field, this is the name, this is the type, size if it's a string, and this is how you calculate the value. So you can add as many as you want, it's flexible, you can attach them to existing data sets and say, hey, add this field, add this field. And it's very dynamic compared to like design time, calculated field. I mean, that is a bit rigid in that area. It becomes very flexible. And with this code, there is a little bit of code to do. There's this commit to do a call at the end that would actually do the cleanup and everything. So it's not completely smooth, but it's actually fairly nice because you have a kind of bunch of this. You comment. I mean, again, this is more flexibility. The fact that each calculated field has a definition and the code to actually compute the value. Okay, so not staggering, but yeah, here's another one. Add extra code, field code. And there are two implementations. Actually, the code is fairly complex. I'll skip it. One area that anonymous methods are really great to use is for doing anything in terms of parallel computing. So the parallel library that was added 4 versions ago, I see 7, I think, I'm not sure, some time ago. The parallel library is actually a very nice example of how to use the anonymous methods to attach behavioral logic to things that it's likely going to be executed as a background task. And it uses the term task for the advantage of the parallel library compared to traditional multi-threading is that it provides a further abstraction layer. You don't have to think in terms of, okay, how many threads should I spawn on this computer depending on the current CPU and cores and workload to have the optimal throughput. You say, create a bunch of tasks and then let the library do the proper balancing in terms of thread creation, thread pooling, and everything else. So again, gives you one layer of abstraction on top of the physical CPU, which is nice, and also provides some logic to really abstract even more, like the parallel for. I want this code to be executed in parallel. You don't have to create tasks or threads or anything. The system does it for you. Or futures. I want this value to be calculated whenever you have time. Type of model. So I'm going to spend 2 minutes on this because who's actually using the parallel library? It's not. Okay, yeah, a few hands, as I was expecting. It's fairly newer than other stuff we've seen. So. Anyway, we go through the short roundup of the parallel library with these 2 demos. One is I think it's a fairly classic for loop, standard version and parallel version. Notice this code works exactly the same on iOS, mobile, Mac, all different platforms. So again, it's fairly abstracted from the core platform. And I could say, I mean, it will use the desktop cores better than the phone cores, but these phones have more cores than this virtual machine at least. So it would be unbalanced. The phone has more cores. The virtual machine has about, I think the virtual machine only has 2. So anyway, yeah, I mean, final demo, then we get to the code. But yeah, sure, this demo. And then we get to the code. There's a fairly good old traditional for loop. It's computing something in 400 milliseconds. Sorry, the font is small. And this one takes, surprisingly, exactly half of the time, which is, we've been lucky, it's only a little more than half of the time. But roughly it's 200 compared to 400. And the only difference in the code is that here I have a for loop and I'm executing these 2 lines. And here I have a t-parallel for loop. It's not a loop, it's a function call. But I call it t-parallel for, and I'm executing almost the same 2 lines. Not the same 2 lines, because I need to make sure that if I'm accessing a shared resource, like this variable, I make it thread safe. So using parallel, interlocked increment rather than the traditional link function. So there is a slowdown here, which really means also because interlock increment is pretty fast. So the slowdown here is pretty minimal, and there's an advantage because it's going to be executed by, in this computer case scenario, likely by 2 threads in parallel. And it's an algorithm that's easy to parallelize, not all are, because there's no dependency. But still, I mean, you're gaining a 50% increase of the time just by restructuring the code. So not a bad thing. However, it's not only that. Again, as I was saying, the concept of, and this demo is a mess, and I got complaints yesterday. You shouldn't sleep in a task. Okay, I know, it's a nice day. So this is how you create a task. A task has, well, a task is an anonymous method, basically. Everything, all that matters in the task is the anonymous method be executed when the task executes. So anonymous method create, procedure, begin, end, and you write some code. Okay. In this case, wait some time and shows hello. And then of course you have to start it, otherwise you can wait a lot of time. It's never it's good. I mean, nothing's going to happen. So fine, I'm not even going to run this. Now look at this second one. In this piece of code, we are creating two tasks. And we're saving them in an array of tasks. A task is an interface, iTask actually, that's what matters. So we're creating an array of tasks. It's dynamic, so set times 2. This is the first one, 0, this is the second one. And one takes 3 seconds, one takes 5 seconds. And then we say we start both. I mean, the two start to be down here. It doesn't really matter much. And then we say wait for all. On the way, everything to be done. So the first task is 83 seconds. Second task is taking 5 seconds. What's the total time we need to execute this code?
2 seconds.
5 seconds, the longer of 2, because you have to wait for the second to be done until you can continue. So roughly 5 seconds. And again, sleeping is not even a great idea, but whatever. It kind of explains the concept. So yeah, in 5 seconds you have 8 seconds time of work, or do nothing, done for you by the computer. So again, it's kind of fairly simple. You can do wait for all, wait for any. The first is done, continue. Don't wait for the others. I mean, there are a bunch of ready-to-use things that are built into. The last thing, and again, I could spend more time on more detail, but the last thing that actually is probably the nicest one. What is that? It's button 3. I want to create a future. What's a future? It's something you don't have now. You're going to have it in the future. So it's a generic interface, but the point is, the concept is, I want a value, but I don't want it now. I need it later. So I want to have I have this variable. It's basically an integer. It's not an integer. It's a future integer, but say it's an integer for all practical purposes. I have this value. It's an integer, and I have some way to compute something. So you're basically using a task or the same code you write in a task. But the difference that a task is a procedure, a future is a function that returns the future time. Okay, so that's kind of the core difference. Task, procedure, future, function. It's returning something. And saving it automatically in the value. So you say, I have this future, this future, and then you do something else, and at some point you are using it. One value dot value. Using the value of the future. And at this point there are two possibilities. One, during the rest of the code execution, there was some free processing power, and so a thread already computed the value. And so here you have the value, go ahead. Second option is the CPU was busy doing other stuff. This is not available, then you will stop here, compute the value, and then continue with your code. So both ways, you don't have to worry about, is the thread finished, is the calculation ready? You just continue, you just say, okay, I need that value and in this calculation. If it's not ready, it's going to wait for you. If it's ready, good, it's going to be faster. So again, simplifies and removes a lot of the boilerplate code around using threads in a fairly smart way. Now, all of this does not imply that this is threading. Threading is dangerous. Threading can mess up your code in unexpected, surprising ways when it's during demo time, because threading is not trivial. So don't underestimate the complexity of resource access, resource conflicts that can deadlock an application fairly easily if you don't know what you're doing with threading. Like two threads, one waiting for the other, and they get locked, and the application is, they have to kill it, there's no way out. So again, put some care in it, but still, it's a fairly powerful feature to have. Not in the language technically, because it's part of the runtime library, but the distinction is kind of moot. I mean, we'll get a complaint, oh, but you haven't added parallel programming in the language. Sure, so you're saying that in Delphi Pascal there is the T object as the base class of all classes, and it's part of the language. Yeah, oh wow, but it is system that passes, not in the compiler. And this is insistent threading. Okay, yeah. So the difference between the core RTL and the language at times is kind of moot. The reason I personally don't think they should get into the language but remain into the RTL, because for example, this parallel library comes with a thread pool management logic that not only is part of the source code so you can read it, it's better than having like built into some automatic black box. Not only that, but there is an API to replace it. This is my algorithm, which is better than yours on this platform, the Raspberry Pi algorithm, just whatever. I mean, there's a platform, I have better code than you have, you can just plug it in. You can use the same exact source code, but plug in your own task manager and optimization and thread pooling algorithm. It's completely open. So by not having it in the language, you'll earn in terms of openness. Although it's true, it's less integrated, less core to the product. So you could debate for a lot of time. System threading, reflection. Reflection is an RTTI on steroids. Again, don't want to put too much time in terms of going in theory, and I'm not even going, well, I'm going to show RTTI at some point. So this is, let me show you the actual application first. So this is a list of things, okay? And it happens to be that the list of things comprises objects of different types. It comprises a company, Acme Inc., and a person, or Coyote as you prefer, whatever. It's called Willy. So it's a list of object of mixed types. Okay, yeah, I mean, we've done object writing programming 20 years, we know how to handle that stuff. Well, yeah, but this does it differently. So it does not use a common ancestor class with two methods, give me the ID, give me the description. It does not use an interface, which is like the actual more modern way of doing the same thing with the common B table. It uses RTTI and attributes to decorate methods that can have different names, classes that can have different base classes, be in completely different hierarchies. As long as they're decorated with the right attribute, they can participate. So it's more dynamic, it's more error-prone, it's slower, but it gives a huge amount of flexibility compared to, oh, this is my hierarchy with 125 classes all together. Okay? So in practical terms, if you look at the code behind it, okay, there is an attribute. Okay, you can define attributes as you want. It's just a class that generates some attributes. Very easy. There is a kind, because you cannot put the attribute different things. And specifically, you can have an attribute that says this is the description, and another that this is the ID, which are the two elements that we care about. And then another attribute for the class. Hey, this class has the right attribute, so you can mark the class specifically. So the difference between a regular class and this class is that it has a description attributes here. It says, hey, this is the function returning your description, and this is the function returning your ID. And the function name does not matter at all. Okay, and you can even be flexible on return time. This is another class, and it has, which one of the two is different? Okay, this ID is attached to a function of getScreen code. This is attached to a function of getScode ID. So they're not, you don't inherit, they're separate classes. You don't even use the same function names, but using attributes to mark them. Now the code to do the execution is a little tricky because basically, well, it creates two objects, that's the easy side. Doing the parsing takes a little because it has to go through the list of the objects. It has to check if the class is marked with the attribute. Then it has to go through all of the methods. For a method in type get methods, for an attribute in the method attribute. So it goes to the list of the methods, goes to the list of the attributes for the method, because you can have multiple attributes. If it's found description, grabs the value, finds ID, grabs the value. And what it does is a method invoke. So it's calling the method in a completely by name, not even by name. It's calling the method that has the attribute. And grabbing the result. So it's extremely dynamic code. But we can do even more dynamic code. It never stops. And for this one, I mean, the code is attached. It's kind of a mess. And the original code came from Barry Kelly, who was a compiler engineer quite some time ago. So the point here, this is an execution environment for scripts, and the script language is really bare bone, for scripts that hook into this application. So you can say, and I'm sorry, the font, okay, I'll say what I'm typing, so I'm saying, let I equals 10, kind of odd syntax, and now the result of this operation is 10, and if I query for I is 10. So it's assign a value to a variable in the script. Okay? I say, yeah, okay, I mean, what's the big deal? Well, but I can also say, let is for create, let f equals t4 dot create. Ooh, yeah, it says parameters can't be mismatched because you know what? You need a parameter. Let's say nil. That should work. We have created a form. Okay? Now we have the form. We say f.caption equals ADUG. And we've done something. We don't really see it because we haven't called form f.show. Now there's the form with a caption. What you can do is you can create your script, and I actually have the script. I can try to learn about it. It's not really bad. You can create a script, does all of these operations dynamically, and this hook into your code, your database object, your form. They can use any published or public property or method of your object. And the advantage is that at times you need this flexibility. At times you need business rules that are not compiled into the code because they change every day. And then sending a script file is a little better than sending over like a new binary for your application. So the ability, when needed, when useful, to have some dynamic code that hooks into an application is actually powerful. And there are better scripts and tools that do that. I mean, this is really only a proof of concept, kind of very low level. But the concept is relevant. I mean, it's important to have that flexibility when needed. Okay? And again, the code behind is tricky, so I'm going to skip it. And I think I'm also going to skip the, yeah, it's late. If you haven't seen this is great. It was like quite some time ago. There's a technique in the language that lets you intercept virtual method calls and do something before, after, or instead of calling the real method. So you have an object in memory, has a virtual function, you say, yeah, I want to know when this is called. You install a virtual method interceptor. That's pretty tricky. Yeah, before notify, after notify, and also an exception. You can trigger some code. So you can create proxies. You can modify the runtime behavior of a class by replacing dynamically for one object, not a class, one individual object, replacing the virtual method head. That's, yeah, I don't know if I want to do it. Class headers I'm going to skip. I'm going to touch on some of the new features around mobile and some of the features that trickle into the Win32 side of the language from the mobile side. Right? So the big change in mobile is automatic reference counting. It's a complete new model of memory management for the language. We can debate for a long time the goods and the bad. Just going to show you how it works a little bit. So the point is, you create an object, it's like for a string. I mean, do you really care about freeing strings? They work. So the concept is trying to bring the same to objects. Now it's a little more tricky because strings live in their own world. Objects have the bad habit of referring to each other. And even referring to each other and back, creating reference cycles gets a bit in the way. So it's not that it would be very easy to manage objects in memory, but they have this habit of referring to each other. It's this annoying object. So again, by default, if you're using an ARC-based version of Delphi, everything is tracked and objects just go away when they go out of scope. But there are issues with, again, cycles and other scenarios. Now there are two techniques you can use. The most important thing is that you can use a concept called a weak reference. A weak reference is a reference that from one object to another that does not increase the object reference count. So it doesn't count in terms of keeping the object alive. When the object happens to be destroyed, however, weak references are managed. That means that when the object is going to be destroyed, the weak reference is going to be set to nil. That's different than, I mean, in Delphi, if you have two objects referring to one to the other, yeah, you can free the object, and then you have a dangling reference. So if you're using that pointer, you can even check if it's nil, because it's not going to be nil. It's going to be this memory location, but you don't know if the object is still there. That gets tricky. Weak references are managed, means there is an overhead, a runtime overhead, but if the object is destroyed, they get set to 0. So that's not bad as an underlying mechanism. Now let's get to see some code, and I might not even compile it because I need the device and everything. I mean, I have the device, and I have everything configured to deploy to Android, but it's going to take a little extra time. So, okay, let me start from actually this code. Okay, goes back to the other side. So, this is a very simple piece of code. Create an object, do something, goes away. The object is going to be removed and destroyed because it goes out of scope. So here the reference is 0. When you assign, the reference goes to 1. Here the reference goes back to 0 because the reference goes out of scope, so it's decreased. Gone. The object is going to be destroyed. Okay, but now when you look at this object, which is a little more complex, what is that? Oh, it's in the unit. When you have this object, tilde my little class, it has an owner, which is another object. And the little class owns the object. So again, here we have a cycle. But what you can use is use a weak reference to break the cycle. So by using weak, you are disabling, I mean, this will refer to the owner, but will not increase the owner reference count. So when the owner reference count goes to 0, the owner is destroyed, and the owned object, the only reference was this one, so this is also destroyed. So both objects are destroyed when the owner one is destroyed. So it's a little tricky, but it can really handle some pretty complex scenarios in a smooth way.
So this is only on the mobile compilers?
This is in all of the new compilers, so Android, iOS, the ARC, the simulator, and the Linux compiler.
But not VCL?
Not VCL. No, we'll never get ARC for the VCL. That would be fairly tricky to adapt the code, so it's not really planned. In any time in the future, at least for now.
Marcus, in 10 minutes.
Sure, okay. I think this other demo has the same code. I don't know if mine's different. Yeah, it tracks the reference counts a bit, so I'm going to skip this one. One advantage of having reference count is that you can write this code. It's a classic example of operators overloading, but with classes, not with records. Okay? And you can say, what the heck? I mean, what's the relationship between memory management and operators overloading? Temporaries. Because if you write this, a plus b, okay, a plus b, you get a return value, you assign it to the variable. Well, what if you write this? You're creating a temporary. The compiler can handle it. Yeah, but it's going to stay in memory if someone doesn't destroy it. So this code on Windows will be like disaster. Where with ARC, it works out pretty smooth. So the compiler with expression that use operators tend to create a significant number of temporaries. And if the memory is managed, I mean with a garbage collection or with ARC, you can handle it. If the memory is not managed, it's really not workable. I mean, we could enable it if the compiler supports it, but then memory leaks would be a big issue. Okay, so let me go one step further, and we can even get to the final demo. So this thing about, as mentioned, this thing about ARC and weak references is ARC platforms only, so mobile and now ADUG. However, some of the features that we started introducing with ARC trickle down to the Win32 compiler. Specifically because there is one scenario in the Win32 compiler where we're having cycles, a reference cycle and cross-reference gets you in trouble with memory management. When is that?
Interfaces.
Sorry?
Interfaces.
Interfaces, exactly, because interfaces are reference counted. It's been since Delphi 3 or whenever they were introduced. However, when you have cycles, you get in trouble. So from the concept of interfaces, of ARC, we've moved, and that's pretty new, because we introduced in Berlin, we've moved the concept of the weak attributes to interfaces. So these are just two objects that can refer to each other. So one at object 2 and 2 at object 1 to create the cross-reference. And if it's a strong reference, those two objects will stay in memory forever. Unless you go and set nil to one of those sub-objects. Using a weak reference, everything works. And still, when you are within the code of this object, you can check if another object exists or has been set to nil. So you can still have safe code, although you have to check it. It might be destroyed for some reason that's outside of the class. But still, there's a smooth way to check memory status and remove the object. Okay, so weak is important because it allows you to disable, manage the reference in a different way. Avoid the reference count, but still have an empty reference. However, not only that is important, but at some point you might say, what the heck? I mean, weak is adding overhead. The reference count is a mess. I don't care. I just want to use a good old feature that comes from Object Pascal 1, which is a pointer, or something that is very close to a pointer. I manage the memory. I know what I'm doing. Who cares? And you know what? You can do that now for interfaces in the Win32 and Win64 compilers. You can actually disable reference count by declaring a variable unsafe. Unsafe doesn't mean you're getting an access violation. Meaning it's unsafe in terms of memory management. Meaning you manage memory. I mean, the compiler said, I give up, you do it. I mean, take care of it. So in this code, having unsafe will leave the object. The object will not be the reference as you expect for an interface. You disable the behavior of interface altogether. Unsafe is available on ARC. It's actually quite handy. I mean, for example, on a T component, where T component has its own memory managed model. Originally, we started declaring weak references inside T component, but what the heck? There is a memory management model already, notifications and everything. So now we reverted to unsafe. You don't need to have ARC for those objects because there is another system in place, and the two will conflict and get you in trouble. So that's actually, so unsafe is saying, hey, so ARC is compulsory, but each individual instance you can determine if it works the standard ARC, weak or unsafe, and the same now for interface references in all platforms, including Win32. So for example, when you're mixing objects and interfaces, that's always been, oh, never mix objects with interfaces, you can now do it. With unsafe interfaces, you can mix in objects. I mean, memory management becomes a traditional memory management. You're done, it's for free. Good for you. It doesn't mess up with your interface reference. So it's a very small language feature, but kind of nice to have. It brings me to the last language features. Let's still have 1 minute, 5 minutes consideration. This one was introduced, I think, XC7, which is the ability to concatenate and initialize with a static array a dynamic array. I mean, dynamic arrays are great, but they used to be more harder to use. Now you can use dynamic arrays in traditional array ways. So this is creating an array with 1, 2, 3. This is adding to an array. This is adding some fixed values to a dynamic array. This does not work in versions up to and including XC6, if I'm not wrong, was introduced in XC7. Around that, or Seattle, around that. And also, the core RTL for arrays, like operations, actually for strings mostly, operations like insert or delete have been added to dynamic arrays. So it really makes it much easier, much more flexible to use dynamic arrays these days than it was in the past. Okay, having said this, I've gone through XC7. So, one final consideration. What's in the roadmap? Big feature coming along is nullable types. What's a nullable type? It's a type that can have a value or no value. And no value being distinct from 0, empty string, FFFF, or whatever odd value you're assigning to imply, well, that's a special value. We'll be having days on generics, interfaces, and a bunch of other features to get combined together. But the point is, you create something that looks terribly like an integer, but you can assign null to it. And then you can query if it's null or if it's a value. Of course, you will always be able to assign an integer to a nullable integer. You won't be able to do the opposite. You'll be able to do it with a cast, and the cast might fail in case the value is null. Assigning a nullable value to an integer will raise an exception. Can do it like an as type of exception. So it does introduce a lot to the language. It can be done at a higher level, but doing it at the compiler level, like mixing those in expressions, I mean, really merging it at the language level is tricky. Trying to do it, and hopefully we'll do it right. And so that's going to be a huge change. One side effect of having nullable types is what's called hoisting. I mean, take this classic example. I want to save in this integer the position of edit box. How do you get the position editing box? Form 1, dot edit 1, dot left. Easy code. Oh, well, what is form 1 is not assigned. Oh, okay. If assign form 1, then form 1 dot edit 1. Oh, what if edit 1 is not assigned? If assign edit 1, if assign form 1 and assign edit 1 form 1, you keep going. And if for a complex expression, that would be like drag. But you have to write safe code. So yeah, you have to check the assign. The hardest thing about that, if you say nullable value equals form 1 dot edit 1 dot left, there are two options. Form 1 edit 1 exists and you get left, or they don't exist and you get null. You don't get an exception, you get a null value. That's nice. That's how like short does is kind of growing a bit of that. So it's, I mean, so because at the time you think, oh, null, but I don't do database, I don't care about null value. Well, null is pretty pervasive. I mean, you have nulls in Jazz and you have nulls in database, but you also have, I mean, null is also used in the application logic. If something might be there, or you might not have a value because the current application status is such that you don't have a value, just write the code. You remove the if statement, the if assign, all of that boilerplate code, and you go to the body. So it can be a significant addition. Now to do it, we need to, given this record, we need some code to initialize and finalize records. So we're likely going to add that as a language feature for everyone to use. We also have a bunch of syntax enhancements and code optimization. I mean, making the compile code faster as kind of part of the plan. For the next year, and with this, 22 years and counting, the language has been and will be enhanced. We did just some copy of every feature we see around. It's been done. I don't want to get there once more. And I'll skip the examples there. 1 minute left. Any questions? Yes?
Dynamic variables.
Sorry?
Dynamic variables.
What do you mean by dynamic variables?
Similar to, say, var equals x to 4 or something like that. So you don't have to worry about, similar to C#.
Yeah. Well, it's one of the many things we're considering, but it's unnatural. We'll get that. We have a fairly long list. But
It's a nice one.
I have to say.
Multiple return values as per jar.
Multiple return values, that's very high on my list. The ability to do, to have a function that returns, and then returns something else, and then returns something else. That's a pretty cool feature. That helps a lot with enumerating, processing large data structures. So that's pretty high. But again, it's one of the features. It's in the quality portal, so go quality.mrko.com. Look for new features, search for language, and vote for the things you prefer. We're looking at those votes, honestly.
Well, 1, 2, 3 quick questions? Or make quick answers.
You were talking about the underlying reference on interface references. Can you apply them to parameters to functions or returns to functions?
Yeah, it's a little more tricky, but there are a bunch of things you can do with parameters. You can have const parameter, var parameters, but you can also have unsafe parameters or declare unsafe the local variable within the function. So there are tricks to remove the entire set of reference code. I actually have some Linux code that usually has, there's an entire piece of execution that has 0 reference count. It's completely removing it with a bunch of different means, from unsafe to const parameters to a bunch of other stuff. So.
That was a yes.
For someone who's been doing VCL for 22 years, getting head around ARC, now I'm sure there's plenty of resources, I'm not sure about maybe code rages and things. Is there a definitive Embarcadero kind of, examples and just detail to clearly understand the issues and in moving to,
the definitive no. There's a white paper I wrote, there's a book I wrote. The book is on the stick, so there's a chapter that has quite some kind of, but it's not, neither of those is an extensive reference.
Okay.
It's more of an introduction.
Last question up the back. Okay. Okay, I've got a couple of questions.
Now, one thing I wanted to show before we go, where's that? That's the thing that I mentioned before. I loaded both sessions, Delphi language and WinTag, on GitHub Michael Cantu learning sessions. So you can grab those, and there's the entire source code. Which I probably never going to update, but whatever, let's put it on. It's free. I mean,
Okay, rubber hits the road. You've just spent a day here. Who has learnt something new? Something that they did not know before? Hands up. Fantastic, okay, that's 98%. 98% of participants learned something new. Fantastic. More importantly, who has written down something that they have to go back on Monday to do? Okay, so this is the question. Will your behaviour next week change because of something you've learned this week? Where you go, I have to do that. Okay, which, yeah, at the end of the day, if we can provide you with value, with more knowledge and with things that will make you more productive, make life easier or whatever, then we think we've had a